What in the hell? Oh, one of these deals. One of these deals, fellas. Welcome everybody to Tonepriest. What are we doing today? I'm going to show you how to do a tube amplifier field test. So if you are trying to make a deal with somebody in your local area and you meet them in a Wendy's parking lot to buy a vintage or modern too, this will work on modern amps too, tube amplifier, all you need is a very simple tool and you could potentially save yourself a lot of heartache. Alright, if that sounds interesting to you, hang tight. Here we go. Alright, so for our little field test here, we are going to test the continuity on the primary and secondary windings of our power and our output transformers. Now, it's helpful to understand a little bit how a transformer is constructed. So if we're looking at a transformer, at the inside there's the core, and it looks like this, and they have cutouts in them. Alright, so this is a little view of our plates. That's all metal. And what they do is they take a relatively thin piece of wire and they wrap it around tens, hundreds, or thousands of times for your primary and for your secondary. Oh, this is getting tricky. 3D baby. What this does is, let's say for instance, this is our power transformer, and this is connected to our plug that goes into the wall. Alright, there's a plug. And so we're taking 120 volts. I'm going to have to flip this over for you. I'll just draw it on the screen. 120 volts from the wall. And what we need to do is our tubes need a lot more than 120 volts. They need like 350, 400, some amps even higher. They need 400 volts on their anodes or their plates. So, due to the winding ratio, either the primary or the secondary, they have different amounts of how much wire is wrapped around the metal. And what that does is it'll take your 120 volts from the wall and it will step it up to, like, we'll say 350 volts. And that's why we use a power transformer. That's called a step-up transformer. And the same thing also kind of happens with the output transformer. We're taking high voltage, low current signal, the guitar signal, and we don't want to send high voltage to our speaker. So we're lowering the voltage, and as a result, we're bumping up the current. And that's why we use an output transformer as well. We're stepping it down. Does that make sense? So what we need to do is we're going to make a measurement with our multimeter. And any old multimeter will do. You can get the cheapest $5 Harbor Freight multimeter as long as it measures DC resistance. We're going to put one probe here. And we're going to put the other probe here. We're going to measure DC resistance. I'll make them look like probes. And what that will do is that we'll see if we have continuity all the way through the winding and back out again. Now, this test doesn't guarantee you have a good transformer or a good winding, but if you do not have continuity here, it guarantees that you have a bad one. So, the more you know, I guess. Alright, let's break out the amp and do our tests. Here we go. Alright, what do we have in here? What is it, Sienna? What is it? Need a knife. Won't work. Alright, I won't make you sit through this. We'll go fast motion. Here we go.
Okay.
A little bit of rust here. all in all, not bad. Nice little cage, so we won't get burned by our tubes. I like it. All right, next. Boom! All right, look at this little honey. Knight KM15 Hi-Fi Amplifier. Phono tuner. Oh, that feels pretty good. Feels good. Oh yeah, not bad. Not bad at all. Oh, this one's a little stiff.
That's what she said.
Which one is this? Volume? Got some stiff volume here. Tube sockets look nice. Transformers aren't too rusty. Got a little bit of rustness on the bells, but the what do they call these? The plates, wafers, whatever, are not all full of rust. This cord's going to be replaced, obviously. Obviously. Look at that. So if you're out in the field and you are able to look at the guts, you want to see if there's like any signs of like anything burning or exploding, any scorch marks or anything like that. And I'm just looking through the viewfinder here, but I already looked at the pictures on the listing, and she seemed like she's in real nice shape. This is some wax capacitors. This is some vintage friggin' technology right there. But point-to-point construction. Very beautifully done. Very nice. All right, let's do our little test here. We're going to break out the schematic, and I'll show you exactly what we're doing in this amp in question. Knight. The Knight time is the right time. Hang tight. Alrighty, here is the schematic. Actually, this is probably better for you this way. Can you see that? Hopefully you can see that so I don't have to send this off to Pixar to make graphics for this video. Mr. Pointer! We haven't seen Mr. Pointer in a while. He's back, baby. He didn't go anywhere. He's still here. Alright, here's the schematic for our Knight KM15. And right here is the schematic symbol for our power transformer. Here is our output transformer. And so what we are testing are both the primary and secondaries of both our transformers. Let's move you over here a little bit, put you in the middle. Okay, here is our plug. And what we want to do is we want to make sure we can read DC resistance from one prong of the plug all the way through the winding of the transformer, the primary, and all the way back to the other prong. If you'll notice here, we have this little arrow symbol. That is the symbol for a switch. That's the on-off switch. So when we connect our probes, we've got to make sure that the switch is in the on position, or we will definitely not have continuity. That'll be the primary for the power transformer. The secondary, we have a couple of spots here. We have the heaters of all the tubes. It has a couple of different windings. So one for the heaters. And what else do we have here? We have one that goes to the rectifier tube. And it says we can use either an EZ80, EZ81, or 6BW4. But we're in America, so we're going to call it either a 6V4, 6CA4, or a 6BW4. I purchased a 6CA4 on eBay yesterday. That's what we're going with. So what we need to do is test on both sides just like we did on the primary. We can do that for the rectifier tube winding. If we look at our pins, we need to put one probe on pin 7 and the other probe on either pins 1 or pin 8. Apparently they're connected. We'll confirm that when we connect the multimeter. And then we also need to test the heater windings, the 6-volt heater windings. All right. And then over here, up here, on the output transformer, we can put our probes on the pins of the tube sockets that are for the plates of our two output tubes. So if we look here, this straight line is the plate or the anode, and that connects to pin 7. So we're going to connect one probe to pin 7 of both the power tubes. And then for the secondary, we are going to we can probably put one probe just to the chassis for ground, and then we can test our 4, 8, and 16 ohm taps of the output transformer. Simple stuff. All right, let's do it. All right, can you see all that? Here's our multimeter. We have the dial set in the DC resistance position, or the symbol there, omega, ohmage. And the first thing we're going to do, like I said, is test the primary of the power transformer. So we're going to attach one probe to each prong of the cable. And hang on. Get on there. There we go. We have continuity. It's wandering around because I just don't have a good connection. And like I said before, if we put the amp in the off position,
yeah, we got a word for that kind of odd in English. It's called suspicious.
All right, so we have something suspicious going on here. The amp is in the off position, switch is off, power switch is off, and we're still getting continuity. Turn it to on. So we have 16 ohms, shut it off. And we have K ohms, so it's much higher resistance, but what I believe is happening here is we have an old crusty cable, and it's probably got some shorts. The wires are touching each other. That's probably what's going on there. Let's put the amp in the off position. All right, we're going to test the primary of the power transformer winding directly at the leads of the transformer. We have the power cord, and they split it down the middle, and one wire is going to the back of the switch, and this is the wire that comes to the actual transformer after it goes through the switch. So we're going to put one probe here for a test. And then we can see over here, this is where the other wall wire goes to, and this is the other side of the winding. So we're going to put a probe there. So one there and see what we get. You know what we can actually do to take the power cable out of the equation is to just cut it. We're not using it. We don't want to get any false readings from shorted wires inside the cable, so we're just going to cut it. Snip and snip. Alright, so the power cable has now been disconnected from the power transformer. And let's see what we got. We're testing the primary leads of the transformer right at the source. And there we go. 10.5 ohms. Very good. You are fired. Get out of here. Alright, now to test the secondary, we need to put our probes on. Look at our schematic again. Pin 7, pin 8, or pin 1. Okay, which one is pin 1? Which one's pin 8? Is this pin 1 or is this pin 1? When you're looking at the socket from the top down, from where you stick the tube into it, that orientation, the numbers go from lower to higher in counterclockwise fashion. So this is pin 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's put a probe on pin 7 and a probe on pin 1. Boom. 389 ohms. And we could also test pin 7 and 8, I believe it said. Yep, 7 and 8. Do we also get continuity there? Yes, we do. We get the same reading. All right, so it looks like our power transformer is good. Now for the output transformer, we need to figure out who our The output tube sockets, it's going to be right here. So this is the wires that go to the power transformer, output transformer, sorry. And we have pretty standard colors. The blue wire and the brown wire go to the individual plates of our two power tubes. So these two sockets right here are for our power tubes. And we need to check from pin 7 to pin 7. So 987, 987. Boom. 363 ohms. Nice. Should be a good winding. And last but not least, the other side of our output transformer. And you can see we have C for common or ground, and then we have 4, 8, and 16 ohm taps. So we're going to put one probe on the C, and then test each of these 3 windings. And let's see what we got. Probe on C, probe on 4. Oh, 0.3, 0.5, 0.7. All right, this all seems good. So far, we don't have any open circuits in our windings of our transformers. And we don't see any burn marks. Looks nice. Looks like, you know, if we had a decent power cord, we could just plug it in and she should fire up. Socket some tubes in there. She should work. Capacitors, obviously these wax ones, you don't want to power something like that up. Those are almost certainly no good. And the can, who knows? Sometimes these old cans are good. Sometimes they're not. We'll probably end up replacing that. But that will be a story for another day. All right, fellas, there is your tube amp field test. So if you're off meeting somebody from Craigslist in a Wendy's parking lot somewhere, bring your multimeter. And if he doesn't allow you to just do these simple tests, these are very unintrusive. You're not going to break anything, doesn't harm anything. You can access everything for the most part. Yeah, you can access everything without tearing the amp apart. So if they don't, you know, allow you to do that, then look elsewhere for your vintage tube amp purchasing needs. All right, everybody, that's what we got. Hope that helps someone. Rock on. Prosper. Bye, guys.
Done.
Oh, yeah, you know how we roll. How's it going in there? The power of RCA compels you!